mechanics of a problem. This is where most of our mathematics come into play, most of our work. Go to Stat, and we're going to go over to Tests. And we'll go down to the 2-sample t-test. Be real careful not to select the 2-sample z-test. Okay, you hit Enter. Now, from this, of course, you have data, which is what we're going to use now. If we had stats, if we're going to do this by hand, then I would actually have to go in here and recalculate x bar, standard deviation for each of my samples before I would be allowed to put this into it. So we don't want to do that because we have the data. So we're just going to let it work for us. Okay, my X list, or my L1 is my first list, and my second list, of course, is L2. Frequencies stay the same. My alternative is not equal to. I am not going to pool my answers. And we'll look at the curve on this one. I'm going to draw this. Instead of calculate, it'll give you the same 2 pieces of information that are really important. And hopefully we'll look at our picture and we'll see what kind of area is shaded. Sometimes, as on this one, when you look at the area, you're thinking, I can't even see the shaded portion, which means it's pretty small. It means your p-value is very small. All right, and so now what we've done a 2-sample t-test, and we've looked at, we're observing the difference between the 2 means. We find a t-score of 3.766. Okay, now our degrees of freedom we don't see, but if we were to use a degree of freedom, we would actually have to go in and do a t-interval to find that out. Okay, but in this case, our degrees of freedom are actually 7.62, so there's not a lot of degree of freedom in this case. But a p-value of 0.006. Okay, when we look at that, we want to make our conclusion, and so you look down here to finish out our problem, to do the conclusion, interpret the confidence interval, or in this case, we're going to be doing a significance test. To interpret that, you'd state if there were no difference in mean prices, a difference this large would occur only 6 times in every 1,000 samples. That's what that p-value means. Okay, and so that's really a little too rare to believe to be true. Just we got lucky? No. So you would state, so you would reject the null hypothesis and conclude that the people are likely to offer a friend a different amount than they would offer a stranger for a used camera, and possibly for other similar items that were on the list. And that would be perfectly acceptable for your answer here. Consider your p-value. You always want to report back your t-score and your p-value. Relate the answer, your conclusion, into context. Even though you may state your null and alternative and all that stuff, make sure that you put it in context. And so one more time, here's my solution. If there were no difference between the mean prices, a difference this large would only occur 6 times in 1,000. And that's a little too hard to believe for us. It's too rare. So you reject the null hypothesis and conclude that the people are likely to offer a friend a different amount of money than they would to offer a stranger for a used camera or any other items that were similar to that.